And welcome. And this is another episode of 3D Printing News Unpeeled, live with Joris Peels. And today we've got four news stories for you. And the number one news story of the day, and you've probably been talking about it, is Carbon buys ParaMatters. So Carbon is, well, of course, it's a vat polymerization company, came up with the vat polymerization technology. And they were already doing quite a lot with software already. And what they decided to do, they did a lattice, they had a latticing type of software on their own, and then they decided to branch out a little bit. And now they bought ParaMatters. So who's ParaMatters is probably a lot less familiar than Carbon. ParaMatters has a software package that does it does kind of generative design. It's got like you can use it for lightweighting or topology optimization more generally. And that kind of really fits into what Carbon is doing and what they're trying to do. Now, what Carbon has is this idea to production platform. Now, what's Carbon's idea to production is I think it's a very powerful idea. And the idea is that they want you to be able to, just like they're showing in this picture, to go from a sketch straight up to a product with Carbon. Now, I've got a question with this, and that is that, well, if I see all the roadblocks in particle fusion or in vat polymerization, a lot of them are in post-processing, are in cleaning up the parts afterwards, are in kind of like conveyancing, like taking apart, removing the supports, flashing it, washing it, that kind of thing. And that's really like, are they going to go do that as well? Are they going to look at that automation, or is that for other companies? So, but generally, I think it's a very powerful paradigm for, or an idea, a very powerful idea for people who are new to 3D printing. We say, okay, we have one company, one contact, and we master that, and then they're going to bring us to production. So that to me, it's a very powerful idea. Also, this will enable them to make the software from ParaMatters, called CogniCAD, work better with their own software, let people make better parts for Carbon specifically, and that could let them get more value from their existing customers, and maybe get their customers to have more value as well through deploying this more rapidly. Um, so that I think that's an interesting bit of news. And I mean, first, it's a bit strange. We're seeing a lot of like people who raised a lot of money previously have a lot of options now. And Carbon's one of those companies that's cash rich and is able to now, in a kind of more difficult economic time, to really plan its next moves very carefully. So raise early, raise often, I think, is the lesson here. The third thing is a piece of news from it's a research paper on recycling composite 3D printed parts. And it's by Noura Al Mazrouei from UAE University, and it had been published in the journal Sustainability. Now, so what she and her team looked at was a number of ways to recycle 3D printed composite parts. Now, I think this is really important research, and people are looking at it. What they did is they used a twin screw extruder to take these various composites. They then turn them into kind of like a composite plate kind of a material that you could be using for all sorts of other applications. And they measured the results and saw how they could increase maybe tensile or elongation, whatever that kind of properties. And I think it's really important. They're doing this with very basic equipment, and so other people could replicate these results or look into it. I mean, there are a couple of companies like are looking at 3D printing, like Impossible Objects, for example, 9T Labs, um, Arrivo, other companies, Aris, right? They're all looking at commercializing 3D printed composites. And the problem with them, of course, is they're not very sustainable at all. A lot of these parts cannot be recycled at all. A lot of them are thermosets, and they have a material in them like a nylon or a GF or a glass or a carbon fiber strand that actually makes them problematic during production and human health and health to animals and stuff, and also that makes them really difficult to recycle afterwards. So I think if these companies will have to have success with mass-produced 3D printed composites, um, and we're also seeing a lot of these materials in larger prints and that kind of thing, we're really going to have to make this sustainable. And we're either going to have to do things like make composites out of polymer, out of thermoplastic materials rather than thermosets, and or do things like use hemp or sisal or other materials as a fiber that could be, could essentially be burned out once the part's been used. So I think this work is really important, and I think more people should be looking at these kind of detrimental effects of our industry. The next bit of news looks like super unimportant. You're maybe wondering, why is this the number two part of news? What are you thinking here? Um, and it's ATD buying two AOS M290s. So ATD is Automotive Trim Development. This is a company that mainly works in the automotive industry as a subcontractor, and they make engineering components, but also mainly trim and interior components for cars and stuff. So they've recently ordered two M290 printers for their Warwick facility. Now, they did this because they're working on one single component for a luxury car manufacturer. They refer to it as kind of an electromechanical module, a bit vague, but they probably have to be. And they were trying to get the aesthetics of this part, the weight of this part, and the part to function well, and they couldn't do it with the standard technology. So they turned to 3D printing, a technology where they were completely unfamiliar with. They then relied on Additive Minds which is like AOS's in-house consultancy service to, do the optimization of the part, help them print and develop the part, help them install the machine, help them get up and running and all that. And I think this is really wonderful because, like, we have, if you buy a metal machine, it's going to take you 8 months, a year, or something to get it up and running and to figure out how to make things. So any time that Additive Minds can save gives AOS more follow-up sales later on. It helps their customers get up and running. It helps establish the value of 3D printing earlier. And it helps our market grow. So I think it's really smart of them to have this Additive Minds consultancy that really helps people kind of get up and running. I think they're really a force multiplier. I think especially for these kind of complex machines and complex parts, you really do need people that have the knowledge, and these people are really thin on the ground. So hiring them is something that for a player like this would make a sense, because for them to find a person with the experience in metal printing and design, automotive components and stuff like that is going to be super difficult. So I do think that this is like really kind of important. And it's one of these things where I think what's also really crucial for me is that we've heard a lot about 3D printing components from BMW, Volkswagen, all these car companies. We know they use it for short run cars and customization, bespoke kind of cars and stuff like that. And we know it's used extensively in hypercars. And it's starting to permeate through to more normal vehicles. Right? There's several car platforms that have 3D printed components on them at the moment. In really low volume, but still it's happening, right? And we expect a lot from this. But it's all the OEMs doing all of the talking, right? All the car companies themselves are doing the talking. Meanwhile, it's tier 1, 2, and 3 that make most of these components. If we're looking at, like, for example, the interior, the tier 3 guy might make a button or two, and then somebody else makes these assemblies, and then another company like Johnson or something that's ATD could supply the entire interior of a car, like everything, right? In some cases. And these guys really don't have the bandwidth, don't have the knowledge, don't have the money often to invest in trying to come to grips with 3D printing. So I think this is an interesting and good move. It's a really good move for this company. I think it's brilliant for them, and it's also important that we note for the car industry that the OEM is only doing part of the work here, and the OEM cannot progress with this unless they either do all of it themselves, which would be very disruptive to the car industry if they put a lot more 3D printed components that the OEM makes themselves in the car, or to really educate and work with their entire supply chain to get them on board with making 3D printed components. So that's why I think this relatively minor news, because hey, think about it, two M290s with all the stuff you need. That's a quite considerable investment, by the way, for many companies. So it's important to take that into account. So that's why I think this relatively minor looking news, I think, deserves a lot more attention. The next is a bicycle component. This is a component that it's a dropout. So a dropout is essentially, what you're looking at right now is the back end of the bicycle, the back end of the fork, where the wheel is put into the fork, and it's called a dropout in like cool people speak. And this is 3D printed by this is made by a company called Number 22, I think it would be, and together with Silka. And Silka is a company that makes like probably the most expensive bicycle pumps in the world, and they're like $500 on them, and some really high-end components, of which a number of them are 3D printed. So they 3D printed this dropout component. Now this, if you've been keeping abreast of the bike news, has happened before. I think Reynolds did it, EADS did it, I think two smaller bike companies are doing it. Well, what's very interesting, I think, is that a lot of the innovation, a lot of the 3D printing components are happening from small series bikes on small and done by small companies, so relatively small companies. So there's no 3D printing innovation as of yet from Colnago or Shimano and these kind of guys. The larger companies are really way behind these smaller shops that are much quicker to implement these parts. So anyway, this dropout component, yeah, it's all the usual. It's optimized and all that kind of stuff. But I love this because I think this is the future of our industry, essentially. Not specifically maybe this component or biking. I do think we have a bright future in bike 3D printing generally, but just the way this component has been implemented. So this is kind of the gyroidal internal structure. By the way, that's kind of there's a hollow shape in it. You can't really see it very well. On the left one on the left, you could maybe see it, and you're thinking, oh, that's how they got the powder out. But this is also reinforces the part, of course, and keeps it lightweight. This is so far par for the course. But this is a really interesting thing uh, that they have to subsequently, and we never really think about this, but they have to subsequently weld this component to the rest of the bicycle. And what they then want to do is put argon gas through the component in order to then weld it better. And they said that this helps, this internal structure not only helps them get the powder out, but helps them blow argon later on when they want to mate this structure to the rest of the bike. So I think that's a really, really great thing. I had not considered this. It's very obvious, but I had not considered it. And there's another thing that I think is I think maybe the most exciting component about this, and that is the you can see the last generation dropout on the left, and that required five welds more to make. You can even see them on the if you look very closely on the image, and uh, these five additional welds, right? Um, they right now don't have to be done with the dropout on the right, which I think, by the way, looks really amazing. And they don't have to be done now. So that would save this company 20 hours a week. So for a small business, imagine this, you're saving essentially one part-time employee or half an employee a week. And just because you don't have to make these five extra welds on this component because you redesigned it for additive. That to me is a very, very exciting thing to be saving labor today and also to be able to integrate in someone's production process and to save them time where it matters, right? Maybe they don't have these people, maybe they can never get them, that kind of thing. So to me, this is super exciting. I really love this as an example, and that's why it's the number one news item of today. So thank you so much, and for today, and yeah, I hope you enjoyed this.